Okay, number 2. It says physical science was once defined as the science of the non-living world. Explain why that definition is no longer sufficient. Any ideas? Go ahead.
Um,
Go ahead.
oh, okay, sorry. I thought I said hold on. But no, because not all well, physical science is just one science that has to do with the non-living world, and there's more there's other sciences that
Okay.
have, like biology or anything.
I was going to say something more along these. Go ahead. I'll let you try.
Because doesn't biology classify under physical science, and biology is this thing? No.
Physical science is just chemistry and physics. So here's what we're going to put here. The building blocks in PS, physical science, is needed to understand biology. Okay, so you need those building blocks in order to understand biology. They all kind of go together. So the non-living world, we talk about chemical reactions and things like that. Those take place in living organisms too, chemical reactions. Okay, so everything builds on everything else. Number 3, explain why the observation of the sun sets in the west could be called a scientific law. It's just an observation. Okay, there's no attempt to explain it, and it's something that is repeatable that we see every day. All right, so I'm going to say repeatable observation that isn't explained. Okay, which leads us to the next one, number 4. Explain why the following statement could be considered a scientific theory. The rotation of the earth causes the sun to set. Well, they have an explanation here. It's this: the rotation of the earth causes the sun to set, right? So this is an explanation of an everyday observation. So that's why it's a theory. It's an explanation of an observation. Number 5, what is mass and how does it differ from weight? Okay, so we'll deal with this all year long, but mass is defined as the amount of matter, those are 2 T's, in an object. And it's something that doesn't change. It doesn't matter where you go. If an object has a mass of 10 grams, it has a mass of 10 grams on the Earth, it has a mass of 10 grams on the Moon, it doesn't matter. Okay, it's a comparison. Whereas weight, I'm just going to put WT, is the pull of gravity on an object. So even though your mass stays the same, if you go to the moon, your weight is going to be 1/6 of what it was on Earth. As a matter of fact, if you go to, I don't know, the top of a mountain someplace, you're going to weigh a little bit less than you would here. Okay? You're going to weigh a little bit more at sea level. The closer you get to the center of the Earth, the more you're going to weigh, because the more that Earth pulls on you. Okay? So your weight could even change a little bit here. Number 6, some features on computer chips can be as small as 35 nanometers. Explain why you would use scientific notation to express this quantity in meters. Well, we're going to say 1 meter is equal to 1 billion nanometers. So instead of writing all those zeros, we could write it in scientific notation. And then number 7, the mass of a certain elephant is 3,476 kilograms. A zoologist who measures the mass of that elephant finds that the mass is 3,480 kilograms. Is the mass measured by the zoologist accurate? Yes. Okay. The difference is this. What this is telling you is that the last digit is estimated. And so we're using a scale that looks like this. It has 0, 10, 20, and so on, and we're estimating it to be 3,476. What this one is telling us is we use a scale that looked like this. It went 0, 100, 200, and so on, and we estimated it to be 3,480. So the whole idea is when we read a scale, which we talked about this in the reading scale section, we always estimate one place beyond what the scale gives us. Okay, a balance gives us to the 10th place, so we want to write the mass to the 100th place, and we'll have a lot more information out of it. Okay, so that's the difference between these two. Number 8, which branch of science is not included in physical science? Which one is it? D, zoology. Okay, and then let me move it up here so we can see 9 also. So 8 is D. Number 9, which science deals most with energy and forces? Which one is it? B, physics. So I'm going to erase all of this stuff. Is that okay with everybody?
Sure.
And let's look at the rest of the multiple choice questions. So number 10 says using superconductors to build computers is an example of what? A, technology. Number 11, a balance is a scientific tool used to measure D, mass. Number 12, which unit is an SI base unit?
Z.
It's C, okay? A base unit has a standard to back it up, okay? I would probably accept A2 because it's kind of confusing how they talk about base units and standards, okay? They kind of say that it has a standard to back it up, but it doesn't have any prefix on at the beginning of it, which is not entirely true, okay? Number 13, the composition of the mixture of gases that makes up our air is best represented on what kind of graph? A pie graph because it's showing percents. Number 14, in a controlled experiment, what's the best answer there? C. You change one variable throughout, and the other variables are fixed. Then number 15, written in scientific notation, 0.000060 is, it should be letter B, and let's explain it here. We always want, in scientific notation, we want an answer between 1 and less than 10. Okay? And so if we move the decimal point 1, 2, 3, 4, 5 places, we get 6.0. Okay? And since we moved to the right, it has to be negative to the negative fifth. Okay? That's how we end up with that. Let's move it up to see, I think 16 and 17. Number 16.
B.
When studying a molecule, a chemist might make a model of the molecule to, somebody said B, help visualize the molecule. That's the whole purpose of a model. Number 17, the maximum depth of a certain lake is 244 meters. How many meters are in a kilometer? 1,000. So this would be how many kilometers? B, 0.244 kilometers. And let's move it over again. I think on this page we did 18 through 21, is that right? Do we do 22 also or not?
No.
Okay. So 18. Do laws ever change? Do they?
Not really.
Yes.
Yes. And it says explain. I'm just going to say new observations. If we have new observations, we could change laws. Number 19, explain whether or not scientific methods are a set of procedures that scientists follow. In other words, they have to go through, there has to be a problem, then there has to be a hypothesis, then an experiment, then you analyze the data, then you draw conclusions. Does that have to happen in that order? No. Okay? So we're going to say no. Does not have a set order. In other words, you could do an experiment and maybe you get to the experiment part and you think, I need to go back and try this again, then you might start over, okay? Even before you collect the data, just because you think this experiment's not gonna work, all right? Or maybe you get the analyzing data part and you think, all right, I'm gonna go back to the beginning and try this. You see what I'm saying? So you don't have to go through all the steps or you're not a scientist, okay? That's not necessarily what happens. Number 20, which variable is the independent variable on this graph and which is the dependent variable and which is the independent variable? Any ideas? Dependent is which one?
Temperature.
Dependent is temperature, right. Okay, so I'm just going to put it up here. I'm going to say this is dV, this is IV. If you're looking at a graph, it's really easy because whatever's on the bottom here on the x-axis is the independent. Whatever's on the y-axis is the dependent. In other words, we're saying this affects this. It doesn't make any sense to go the other way. Time is almost always the independent variable. I would say 90% of the time. Okay, but if you think about it, if we put temperature here, we're saying temperature affects time, and that doesn't make any sense. That would be like saying it has to be 7 o'clock in the morning, it has to be 50 degrees. Right? That's not how it works. Okay? Number 21 then, why was this data presented in a line graph? Why do we put in a line graph and not a circle graph or a pie chart or a bar graph? Why?
It changes all the time.
Okay, so it's continuous change. Anytime we're dealing with continuous change, we're going to make a line graph. So I'm going to say 21, continuous change. All right? 25, is that right? Questions?
Oh no.
Okay, let me read it real quick. Let me see if I can get all that covered up so I can write over there. All right, so 25 it says, the bar graph below summarizes how a consumer magazine has rated several stereos by price and sound quality. Use the graph to answer the following questions. So letter A, which brand do you think has the best sound for the price? Which one?
Well, I put wall sound because the sound quality is better than the price.
Okay, so Wallsonic.
Oh yeah, the wall sound.
Okay, Wallsonic has the best because it's the only one that has a sound quality higher than the price. Would you agree with that? Which one is the worst? Audio DJ. This one right next to it because it has a very high price, but it has a lower sound quality than, it's not even in the top 3. Okay? So then letter B, you think that do you think that sound quality is truly related to price? Explain your answer. What do you think?
No.
I'm going to say no. As I'm going to say SQ, sound quality decreases, price does not. It's kind of hard to explain what price does. Okay? It doesn't necessarily go up either. It just bounces around. It goes down for a little bit, then it goes up, and then this is higher than this one. You see what I'm saying? So there's really no relation whatsoever between sound quality and price. And then 26, it says the composition of silver solder is 40% silver, 40% tin, 14% copper, and 6% zinc. Show this in a pie graph, so let's make a pie graph here. So 40% of it is silver. If we draw a line through the middle, that would be half of it. So I don't know. What do you think? 40%? Okay. So this is silver. Silver's chemical symbol is Ag, so I'm going to put Ag so I can write it down. All right. And then it says that tin is the same, so it's going to be something like that. Tin is Sn. And then 14% copper. So we have left here 20%. So most of this is copper, and then the other 6% is zinc, which is Zn. Any questions about that? Let's do one more, even though it wasn't assigned to you. Let's do 27. This should be fairly simple. It says, this is just about writing scientific notation. It says write the following measurements in scientific notation. So 22,000 milligrams would be what?
2.2 to the
2.2 times 10 to the fourth.
2 to the 4th.
2.2 times 10 to the
Fourth.
fourth. Well, let's look, okay? I've heard a bunch of different ones. So the decimal point's right here. So if you move it 1, 2, 3, 4, it becomes 2.2 times 10 to the fourth. And it's positive because we're moving it left. Okay, then letter B, 0.000037. So this is going to be 3.7 times 10 to the sixth, you think? Let's count it. So 1, 2, 3, 4, 5, 6. So times 10 to the negative sixth, and what's the units? Kilograms. Okay? All right, if you have a left side page that doesn't have anything on it, which is, I wish I would have been here to help you with that, but I decided I wasn't going to worry about your comp book. But if the left side page across from the chapter 1 review is empty, if it's not, doesn't matter, just put it on the next page. Here is the study guide for the chapter 1 test. And this is also on Canvas. Okay, so if you don't get it before the end, but this tells you what every question is about. I would say a good way to study for this test would be to go back through and make some notes over all of these, because you can use this on your test, right? And I don't care if you shorten some of these. If you want to do this, I had somebody do this. They said 5 through 7 is volume. I had one person do this. They said they wrote volume and then they just put a downward arrow here, because those next 3 questions were about volume. Okay?